we are ready to get started here on stage 2. Now, you've heard a lot about AI and agentic orchestration in particular today. But is it a must-have for business transformation, or is it a risky trend that needs to be carefully controlled? And crucially, can governance and innovation actually coexist to make these technologies transformational at scale for companies? Well, prepare for a healthy debate, and please help me welcome Niall, Deehan, and Nathan Loding to the stage.
Are we doing it?
Welcome.
All right. Thank you, everybody. I have to admit, there's a lot more people in this room than I thought there would be. If I wasn't up here speaking, I would probably be out getting like a snack. So thank you so much for joining us. Niall, are you with us? Oh, I see you talking, but we can't hear you.
Oh, that's not good news.
Oh, now we can hear you.
I'm sure they'll fix that. They're very clever folk.
Wonderful. All right, welcome Niall from literally the other side of the ocean today.
Yeah, I decided not to swim, so I'm staying where I am, staying dry and in the dark, and looking forward to what I wouldn't call a debate, but more of Nathan eventually capitulating to my well-reasoned arguments.
Yeah, so speaking of that, I am the skeptic, which is actually true in real life. AI has a lot of power, it has a lot of capability, but I'm not sure that we're quite there with realizing its full potential yet. And there's a lot of those concerns about, are we adopting it too fast? Are we adopting it too early? How are we mitigating for those risks? And then we have Niall on the other end, who thinks, Niall, put it in your own words.
Well, so I've been working quite closely with folks over the last few months, building a bunch of POCs and things with AI and Camunda. And I did have a bunch of fears initially, but some of the stuff I've built in the last little while have really kind of showcased what's possible, and that a lot of what you might be kind of afraid of is really solvable already. I think I think there's a fine line. We can't do everything, but I think we can do more than people think, while still remaining a relatively safe technology to use in production.
All right, so here's the challenge for today. I'm going to present a series of questions to Niall, concerns that everybody's talked about. In fact, some of the questions that were asked in this room at the previous talk are some of the questions I'm going to be asking Niall as well. And Niall's going to do his best to reassure me, and therefore all of you, that you're in safe hands with Camunda, that we have the answers for you, that we can help make Agentic safe for you and your enterprise. So with that, we're going to kick off with hallucinations. And this is sort of low-hanging fruit, right? Everybody's seen the fun hallucinations from ChatGPT. I was just talking with a colleague earlier where I was asking ChatGPT to write me a blog post. Gave me a response that was way too long. I said, hey, I need it to be shorter. Please cut it down by 60%. It was a blog post about Camunda, and then what it ended up giving me was a PhD thesis on nuclear fusion. Don't know where it came from. ChatGPT can't explain where it came from. There are people in the audience that can vouch for this being a true story. They've seen it. And so we know what those hallucinations are, but something like what I just described doesn't really affect the enterprise too much, right? Like I was a human, I was prompting it, I read the result, it didn't get automatically fed into some systems. But then I stumbled across this tweet recently, and it had me kind of concerned. Now, if you can't see, it summed 1 + 2 + 3 as 15 in Microsoft Copilot in Excel. This is an actual screenshot. I don't know if it's a bug that still exists. I don't know what the circumstances were that led up to it, but kind of makes you wonder what's going to happen if you let AI start making some decisions. So Niall, why should I not be so worried about hallucinations?
I'm very, very glad you asked. Well, luckily I've got some points to go through, first of all, and these are high level. I'm going to try to convince you in two ways. The first is I'm going to explain some practical, things to understand conceptually how to solve the problems, but that's not really good enough for you, Nathan. You're a chap that needs more details than that. So I'm also then going to go into some practical ways to do it. So first we're going to go theoretical and then practical with most of these. And the first point I want to talk about is essentially identifying the likelihood of hallucinations. And this is actually, first of all, the kind of key to understanding a little bit about sort of where the AI can trip itself up, right? So the idea is that there's a bunch of places in which AI is very bad, right? And you can always spot where hallucinations are going to come and where they're not likely to come. Now, in the previous talk, we heard a little bit about how if you train an LLM specifically to do a thing really well, it's less likely to have hallucinations around that. Now, you cannot treat every model and every sort of everything equally. You have to decide on the individual model and actually think about the hallucination that might occur. Now, once you do that, move on to the next point, which is understanding the impacts of those. There's the next kind of important thing. And this is really important because not all hallucinations are equal, right? The difference between, for instance, having an agent that will offer a loan to somebody based on some criteria versus one that describes what a petrichor smells like or whatever, the consequences for doing that are actually very, very different. What you want to do is you want to be able to implement some kind of way to check you get where the potential hallucinations are likely, and then where they're likely to have an impact, add some kind of checks. Now, next up is also important because you can also, as well as being able to just check stuff on the fly, it's really important to actually have a judging mechanism. This is something that I originally thought is a nice to have, but the more stuff I built, especially with processes, it's kind of fundamental. This is a judge that needs to be able to have access to what has happened in the reasoning of the LLM and be able to decide itself whether it did a good job. Now, you may be thinking, yes, but who judges the judge? Well, if we look back on the very first point I mentioned, if you train an LLM to do something very specific, like, for instance, judge the accuracy of something, it can end up doing a really good job. It can end up actually being much, much better than you would think and have much, much fewer hallucinations around that. So, moving on to the practical stuff for you, Nathan. The first point, DMN tables votes constantly tell me you're dead, and dedicated tooling. So these are two things that are so important. LLMs are incredibly bad at things like maths. They can't do that very well. They're pretty bad at giving you repeatable, predictable determinations on things. But you know what's really, really good at that? Dedicated tools and rules engines. DMN stands for Decision Model and Notation. It's another part of the engine that Camunda has. And the way this works is you would basically, any decision that needs to be made that you know can be made in a predictable, repeatable way, add that as a tool for the agent. Do not let the agent make those decisions themselves. DMN, I think, is going to have a new lease of life going forward as a core guardrail for agentic process execution. Now, next up, we of course have the humans before actions. Now, this is a very, very common thing that was really funny because that showed up all the time with POCs. What would happen would be we would have an agent that's able to make all these calculations and then send an email off to somebody. And then everyone's like, that's great, it's wonderful. Can you make sure that it never ever sends anything to anyone unless we have someone reading it first, right, as an example. And this is a perfectly reasonable thing. Now, the nice part about Camunda's AI agent generation, which I'm sure folks have seen already, is that you can give an agent a tool to send an email, for example, and because you can string tasks together, it can that tool chain, that flow could be get a user to approve it first. The AI agent doesn't need to know that it even exists, but that guardrail can exist. And that human intervention can be added anywhere. Email is just an example. So having humans check before specific actions where hallucinations are likely to have a big impact is both really easy and very, very practical as well. And of course, finally, we have being able to use BPMN to pass the context to the judge. Now, I can't emphasize enough the importance of both the judge being trained on the correct data and the data you give to the judge. Now, for folks who've already used Camunda for agent building stuff, they'll probably figure out that you have an agent variable that has all the chain of thought for the agent through all its decision making, all the tools it has access to, all the outputs, and you can give that to a judge to properly assess how the agent proceeded.
So I'm going to ask a preemptive question here before we get to the Q&A, because I just thought of it, and we didn't talk about it beforehand. When you're talking about having another AI as the judge, are you talking about using the same model? Would you recommend a different provider? Is there any experience that you have around that?
I've always used a different model, always. Usually I use a very clever model. In most cases, I don't need a particularly clever model to orchestrate a process, right? And also a process tends to have higher throughput. The judge doesn't need to run on every single instance either, because the judge can also be triggered under certain conditions. So, predictably, like in a deterministic way. And the judge should be a pretty expensive smart model that is able to save you from potential embarrassing actions that a dumber model might take. That's in my experience so far to be true. Let's see how it goes. I've also seen the reverse being proposed, where a very smart model is the one that runs the execution, and a really dumb one is the one that decides on if it did a good job. But yeah, time will tell, I guess. But I would go with very smart model for doing the judge.
That makes sense. And something that you said there kind of leads right into the next question, right? You mentioned that there's high throughput. We know that these models cost a lot, not just to train, but also to run. GPT OSS, you can run it on your MacBook, but you need kind of like 48, 64 megabytes of memory. But if you want to try to scale that up to run 25,000 process instances this morning, you're going to need a lot more horsepower behind that. So trying to maintain those costs, and then also there's quite a few people that have some environmental concerns around the power consumption, right? So how can we make that a little bit greener? How can we bring that cost control down and make it more reasonable?
This is a great question because the hallucinations section is something people talk about on the very first day of a proof of concept or the very first day of a project. Cost is the last thing they talk about when the POC is done. And that's lovely. How much is it actually going to cost us? So let's take the first point there. The very first thing to think about when you're actually designing these is that when agents run, the amount of information that they've generated should be reused whenever possible. You need to be able to store and maintain the actual the value that the agent has given you through acting on a certain goal, because you can learn a lot from how an agent tried to execute things. That's the next point. Actually, is kind of even more like salient, which is actually having proper alerting in place. Because while you learn from an agent running quite a lot, reporting and alerting is actually something people don't think about very early on, but they need to. When I say alerting, I mean having full transparency is one thing about how much your agent is actually using, in terms of even going as far as the number of tokens the LLM itself is using, right? For example, do you want that granularity? Or do you want to know, for instance, how many iterations it's made as part of a looping exercise to solve a problem? Those are all possible, but if they don't have alerting with them, they're going to be forgotten. So you need to have a combination of alerting with reporting, and very importantly, something relatively new. How do you put a dedicated, responsible individual in charge of making sure that these costs are maintained? So now you have SREs and stuff who are in charge of cloud performance and that sort of thing, but this is a little lower level. This is a process running. So you need to make sure that the person who's in charge of understanding these reports and these alerts are able to make those fixes, because these are going to be happening in ways that aren't as easy as just lowering the machine, the power of the machine in the server, for instance. It's a little more complicated than that. So these need to be prepared for. And then finally, on guardrails, is you should probably find a fast and easy way to downgrade your LLM that you're using without completely breaking everything. So by that I mean that it's a very good idea to make sure that after you've got your project done, you haven't built your whole project on the understanding that it will definitely be using a specific model. There's a million reasons for this. One of them, of course, is cost. The next one is that models are changing every 7 months. So there's no point in planning for a single model to run on your agent that you've built. But maybe a really smart, really cheap model is right around the corner. So prepare to change your LLM easily and potentially frequently in design time. That's a really, really good idea. And how do we do all of that? Well, the first thing is pretty easy. With Camunda, once an agent has finished running, there's a huge amount of data that you can store for further use. And I built a POC that was great, in which it actually stored how an agent solved a problem. It then created a execution path for a step-by-step guide on how to solve that exact problem next time. And that was stored in an external data source and then used next time that problem showed up in a deterministic way, which meant the agent never solved that problem more than once. So that's a quite low cost. It's a really, really good pattern, especially for high throughput scenarios. Next up, we have the add programmatic and configurable limits. Pretty obviously in Camunda, you can add specific limits to the LLM, both the number of loops it's allowed to take per execution, which if it runs out of loops, it throws an error. Now, that doesn't mean the process is stopped forever. It just means that an admin needs to basically tell it can continue, or it can say, you've tried your best, well done, but you're going to stop now. And those limits are really, really important and important to add as well. You can also, of course, very easily and dynamically decouple the LLM from the model. In Camunda, it can be a variable. That's simple, either a global variable to change for all processes or for a specific process. So that means that not only would you need to have no requirement to redeploy a process if you want to change your LLM, you just need to change a single variable, which is way easier. And then immediately you would see the impact on currently running instances. That's how fast and easy you can change the LLM for running processes.
Okay. All right, the arguments are working. They're working. But we talked about hallucinations. We talked about how the models can sort of act in a bipolar way, right? You get really good responses one day. The next day you're getting absolute garbage coming out of them. So you mentioned having humans take care of something. Essentially what you're saying is we need the ability to interrupt an agentic process, to be able to interject at some point and say, nope, we're taking over control, right? That's your argument?
I think interrupting is an important thing to be able to do, especially if things get a little bit hairy with how the execution is running. But it's also quite easy to do, but also specifically with Camunda. I'll tell you why. So the first thing to think about is that most agents out there are synchronous, which means when you call them, they're going to run and they're eventually going to try and get an answer to you and then return. That might mean triggering lots of things. Now, an interesting thing you can do in Camunda is you can run an agent for way longer because it's asynchronous. It can run for as long as necessary. But what you can do is you can add BPMN elements that can add as triggers. I'll talk about those a little later on. But it's important to have independent triggers. What I mean by that is you cannot rely on the agent itself to break itself out of a loop. You need to be able to add either independent triggers or independent human interaction to be able to do that. So the agent has no control over breaking its own loop. Rather, you give that ability to other components. Next up, we of course have the granular oversight of tool execution. That is actually, funnily enough, really important in runtime, being able to see what's going on with the tool execution, because there's one thing about breaking out of a loop that's running in a predictable way, right? But there's another thing about being able to say, I don't like how this is going as an admin, right? Looking at this agent run, being able to actually visualize the tool execution and see it do weird stuff how do you interrupt that? So there needs to be the ability to see inside what the agent is doing and have that granular oversight to make decisions about interrupting the agent as an administrator. And then, of course, finally, we have system prompt failsafes. Honestly, system prompts are going to be some of the biggest reasons for being able to properly help interrupting stuff. And that's because if you don't properly give your LLM a way to achieve a goal and a way to fail properly in your system prompt, it'll do the weirdest stuff. You need both. People always give an LLM an end goal in the system prompt, which is a nice idea. It's aspirational, but tell it how to fail properly as well. People tend to forget that bit. It's really important because if you don't, it'll just keep doing random stuff forever until it gets bored. Now, the specific solutions around these, they are many and wonderful. In Camunda itself, you can add BPM elements, like you can trigger conditions that might occur to break out of the loop. Timers can break out of the loop, which is really, really important because you can do things like, here's an example. Let's say in an agent, you have an email that's been sent out and you're waiting for a response from that email, right? Now, in a happy path scenario, we get an email and everything's great, right? Now the agent can wait for an email. That's fantastic. How wonderful is that? But what happens if the person ignores the email? They don't want to respond to it. You need to have events that occur within the agent's scope. Like for instance, I'll wait for a response email for about a day. But after that, I'm going to give up and I'll go do and give control back to the agent. Tell the agent, you waited a day for a response, you didn't get one. Continue trying to solve the problem. So that's like one very important thing about interrupting the agent is that you could interrupt it from doing a task because you know it shouldn't be doing it that long. And you can do that really easily with BPMN. Next up, we have, of course, for long-running agents, transparency and actions are key. Now, I kind of mentioned this in the previous slide, but I want to iterate again. When you're building an agent with Camunda, you have that lovely sub-process, the ad hoc sub-process. And in that, you'll see a bunch of tasks or flows, sub-processes. And in Operate, our front end, you can see how the execution has flowed. And even in runtime, you'll see which tasks are currently being executed. And if the agent is triggering a sub-process, you can dig into that sub-process and find out what it's doing in there. Now, why does that matter for interrupting? It matters because if something unpredictable is happening within an agent, someone's noticed the agent is doing a weird thing, you need to have a lot of context before you can understand how to solve the problem. Making it transparent allows you to do things like, for instance, in Operate, you can cancel a token. You can move, you can drag and drop a token to stop one tool and start another, for instance. But without the transparency of what's either happened or what the agent is currently working on, you couldn't do that safely because most agents are a black box. So that kind of interruption is actually quite good. And then finally, ensure your prompts are tested and built to the best practices. That sentence says it all. I could talk about system prompts as a separate talk for a very long time. I'm not going to because I've spoken enough already. System prompts are where all the errors occur when you finish a project. It's the thing you'll be tweaking for a really long time. Then that's because you start with something that just basically works. You need to look at the system prompt as a core component in your agent, because a whole bunch of things that the agent traps it'll fall into and out of will be a problem. Like I mentioned with interrupting, like in this case, it may never stop if you haven't given it a reason to. So just be aware, system prompts can end up really messing around. And we have a co-pilot now that you can have with your system prompt to help you build a really good one. But make sure you test them.
So what I hear you saying, let me see if I get this right. What I hear you saying is that a lot of the problems with agentic AI are introduced by people not implementing agentic AI very well. Is that what I'm hearing you say? Is that a fair assessment?
No, I think people are an equal part of the problem along with LLMs, because people and LLMs are really similar. They're prone to mistakes. So we need to accept it's the same thing as like who says let's not use this code until all the bugs are definitely gone. It's just not a thing people do. People have to accept a certain amount of responsibility for it. The problem is we used to have a very deterministic framework like code, and now we have a very dynamic framework. But the people are the same, right? So I wouldn't say people are a problem. I think people are so used to deterministic execution of both code and agents that they need to wrap their heads around what it's like to build things that have unpredictable potential.
Okay, so that brings us to the audit log. We're getting a 5-minute warning sign, so talk fast. So we have humans that need to learn. We need to be able to protect our systems. We need to be able to understand. I'm going to skip over the guardrails, if that's okay, Niall.
No problem at all.
We need to store those logs. These are kind of points that we've already talked about today. Keep your variables separated, which is sort of a best practice you want to do with any system anyway. And keep that agent context independent and accessible so that we have that. Now, I'm going to stop talking, which is funny because I haven't talked that much yet. But go ahead and explain how we can do that with Camunda.
Sure, you can throw the points up there. So first of all, a very key thing is the audit log is different from the agent's own memory. Remember that. What the agent has actually says it's done or what it's reasoned is not necessarily what really happened for lots of reasons. Camunda maintains an independent append-only log in ZB, so you'll always know for a fact what's happened. Next, process data, entity data, and agent data are 3 different buckets. Keep them separate. The reason for that is because you want to make sure that you know and understand that entity data is treated like it should be. Process variables are used within the global scope, and the agent is limited to just the understanding you want to give it. And you can do that in Camunda. You can define those different scopes and keep them separate, and then in reporting, bring them all together. And then finally, of course, you can store the agent's own reasoning in a separate file, and this is really helpful because it means that the agent can then mess around with all sorts of weird data and stuff, and you don't have to store it locally, and you don't have to worry about GDPR problems and that sort of thing.
Okay. So I think one topic that we haven't talked about very much at Camunda yet is AGI, so artificial general intelligence. Does anybody actually think that's coming? Is that something anybody's worried about? No? Is this a problem we need to solve? Is anybody named John Connor in the room? No? Do you happen to know where you can find him? No? Do you have some clothes I can borrow? So we had to throw the Terminator joke in there just to lighten things up at the end. But the point that I wanted to bring across, which I argued with Niall about this a lot, like should we include this in the talk or not? And I decided to go ahead and do it without talking to him first, and I sent him a message about an hour ago saying, hey, guess what? This is how we're going to end the talk. Perhaps there's some things that you can't actually fix within a process. And I think that's an important part to talk about when we're talking about AI. We focus a lot on the process and what Camunda can do right now, but also understand that Camunda is part of a larger AI governance plan that needs to exist within your enterprise. Probabilistic evaluations, those are a feature. Like that's why you want to bring an LLM into your business. You want to have that sort of human-like inference that it's making, but know that it's going to be probabilistic. If you need something that's truly deterministic, maybe you should build a deterministic process instead of using an agent. Window and context size limitations, Niall spent a lot of time talking about the audit log and the system prompt and making sure that it has all of the context it needs and being able to pass all of that to a judge. But with AI, we still have a very limited amount of data that we can send it in one go, so you have to be mindful of how you're using that. And then, of course, over time, you'll see bias and model drift happening. And that's something that's happening outside of your process. Your process might be affecting that as it's making prompts to the LLM, to the model, but it's something that you can't fix within the process. That's something you need maybe an AI engineer for, or you're contracted out to some sort of AI service that's there monitoring those types of things for you. And with that, I think we're done. So thank you so much, Niall, for calling in.
Yeah.